Okay, class, today we're in lesson 15.1, two-way frequency tables. Lesson 15.1, two-way frequency tables. Essential question, how can you construct and interpret two-way frequency tables? How can you construct and interpret two-way frequency tables? Well, the first thing we're going to do is to construct one. We're going to construct a two-way frequency table, and then we're going to learn how to interpret them. Making a two-way frequency table. The frequency is the number of times an event occurs. A two-way frequency table shows the frequencies of data that is characterized two ways. The rows indicate one characterization and the columns indicate another. A poll of 120 town residents found that 40% own a bike. Of those who own a bike, 75% shop at the farmer's market. Of those who do not own a bike, 25% shop at the farmer's market. Okay, so the first thing we do if it's not given to us is we construct a table of columns and rows based on the information given. In this case, it's given to us. So we got people with bikes, no bikes, and the total. Farmer's market, no farmer's market, and the total. Okay, now what we're going to do is we're going to follow step by step A, B, C, D, and E. We're going to follow step by step and do exactly what they tell us to do. All right, A. Start in the bottom right cell of the table, enter the total number of people polled. So bottom right cell is here. How many people were told? How many people were polled? 120. So we're going to put that 120 in the total. So the total is 120 people. They told us 120. All right, so we got 120 right there. Notice that's for total and for total. Okay, once again, we have 120 people that were told. Now let's go to part B. Fill in the right column. 40% of 120 people polled owned a bike. 40% of 120 people polled own a bike. So to find 40% of 120, we convert 40% to a decimal, and then we multiply. 120 times 0.40 is equal to 48. So bike, the total who owned the bike were 48. All right, now next we're on step C. Fill in the top row. 75% of those who own a bike also shop at the market. 75% of those who own a bike also shop at the market. So how many own a bike? 48. So we're going to take 75% of 48. To take 75% of 48, you take 75, convert it to a decimal. Remember now, that's like moving your decimal back two places. 1, 2. 1, 2. And then you multiply. 48 times 0.75 is 36. So 36 people, right, who own a bike also go to the market. All right, now look at question D. It's not on your screen because if I put it on the screen, all this will have to disappear. All right, so now look at question D in your book. Fill in the second row. 25% of those who do not own a bike shop at the market. 25% of those who do not own a bike shop at the market. Okay, before we can answer D, we have to first answer this question. How many of the total people do not own a bike? Well, if you got 120 people altogether and 48 own a bike, then how many will not own a bike? It has to be 120 minus 48. And 120 minus 48 should give you a total of 72. So once again, we said 120 minus 78. Excuse me, minus 48. So 120 minus 48 would give you 72. So 72 people do not have a bike. Okay, so now that we know that 72 people do not own a bike, now we can take 25%, part D, 25% of 72. So that'd be like saying 72 times 0.25. And when you multiply that out, I'm gonna have to multiply that. When you multiply that out, you should come out with 18. So we got 18 people who do not own a bike, but they still go to the market. That should be right there. All right, now, because we know the total in this column and the total in that column, we know what this is equal to for the farmer's market. Now we know the total for the farmer's market when it comes to bikes and no bikes, because all we gotta do is add. 6 plus 8 is 14. Carry 1. 3 plus 2 is 5. So it should be 54. Okay, now to do part E should be simple. Part E simply says fill in the last row. In each column, add the numbers in the first two rows to find the total number of people who shop at the farmer's market and who do not shop at the farmer's market. So in other words, it should be easy for us to fill out this last row right here. Now, since I know that this row plus this row will equal this row, then using the inverse math, I should know that 120 minus 54 would give me this number. So 120 minus 54 should give you 66. Using the same technique, 72 minus 18 should give you 54. And last but not least, 48 minus 36 should give you 12. Okay, with that, you now know how to construct a relative frequency table. Okay, now you're going to decide whether there is an association. So in other words, you're going to learn to interpret the frequency table. Relative frequency is the ratio of the number of times an event occurs to the total number of events. In the explore activity, the relative frequency of the bike owner who shopped at the farmer's market is 36 over 120, which is equal to 0.30, which equals to 30%. Move your decimal 2 places to the right. You can use relative frequencies to decide if there is an association between two variables or events. Example 1. Determine whether there is an association between the events. A. 100 teens were polled about whether they are required to do chores and whether they have a curfew. Is there an association between having a curfew and having to do chores? All right, so we take a quick look at the table and we see that our rows are chores, no chores, and total. We see that our columns are curfews, no curfew, and total. Step 1, find the relative frequency of having to do chores. Total who have to do chores, 20 people. So the total of to do chores is 20. Total number of teens polled, 100. 20 divided by 100, 0.20. 0.20 converts to a percent, 20%. Step 2, find the relative frequency of having to do chores among those who have a curfew. So these are the people with curfews. Chores, no chores. Number with a curfew who have chores, 16. Curfew with chores is 16. Total number with a curfew, that's 32. So 16 divided by 32 is equal to 0.5. 0.5 converted to a decimal is 50%. So far we found the relative frequency of having to do chores, and we found the relative frequency of having to do chores among those of us who have a curfew. Step 3, compare the relative frequencies. Students who have a curfew are more likely to have to do chores than the general population. There is an association. The relative frequencies show that the students who have a curfew are more likely to have to do chores than the general population of teens polled in the survey. Okay, Part B. Data from 200 flights were collected. The flights were characterized as domestic or international and late or not late. Is there an association between international flights and a flight being late? Once again, we take a close look at our categories. Columns, late, not late, and total. Rows, domestic, international, and total. Step 1. Find the relative frequency of a flight being late. Find the relative frequency of a flight being late. There is late. Total flights that are late, 40. Total number of flights, 200. So 40 divided by 200 is 0.2. That ends up being 20%. Step 2. Find the relative frequency of a flight being late among international flights. Find the relative frequency of a flight being late among international flights. Number of international flights that are late, 10. International, late, 10. Total number of international flights, 50. International, total of flights is 50. So 10 divided by 50 is 0.2, and that equals 20%. Step 3, compare the relative frequencies. International flights are no more likely to be late than flights in general. There is no association. The relative frequency shows that international flights are just as likely to be late as any other flight.